Hey everybody, good Wednesday morning. We are going to be doing a winter weather forecast update today, looking at the latest pattern drivers as we get into December, January, and February, and want to specifically focus on the topic of La Nina as we go throughout this forecast video, because I've seen a lot of stuff going around if you're on social media about what a typical La Nina looks like, what it will mean for this upcoming winter, and just to be completely honest, it's a vast oversimplification of what La Nina actually is. Historically, La Nina years are very volatile. There isn't really a traditional La Nina one way or the other. There's a lot of other elements when it comes to La Nina that are going to impact our pattern as we head into the winter, and that's what I want to focus on as we go throughout this video today. It's going to be a good one, so be sure to stay tuned for updated forecast analogs for this upcoming winter as well towards the end of the video. But I want to start here just with the notion that there's a typical La Nina, because just to be frank, you can average it all together, right? You can give an average for what a La Nina might look like, but there's not a typical one. This is just the last 9 across the United States in terms of temperature departures versus normal. Now, precipitation, maybe there's a little bit of better similarities with precipitation in La Nina years, but when it comes to temperatures, when it comes to snow, there's a lot of variability. What I have here again on the left, the temperature outcomes over the last 9 La Nina winters in the United States. On the right, highlighted Indianapolis, that's where we're based out of, so highlighted just Indy as a great example. Out of the last 9 La Ninas in Indianapolis, 4 of them have been colder than normal, 4 of them have been warmer than normal, 1 of them was around normal in 17-18, and that winter had a lot of ups and downs. Big warm periods, massive cold periods as well. Volatility is a better word to use when it comes to La Nina. You can see last winter overall a little bit cooler across the eastern half of the country, but 22-23 was warmer, 21-22 was a little bit warmer southeast, 2021 ended the season with a big cold shot, it was a little bit colder, 17-18 for the middle of the country was colder, 16 and 17 and 11-12 were both very warm winters, and then you go back into the early 2010s and the late 2000s and you had some colder La Nina winters. So again, you can't just look at this under a blanket and say, well, it's La Nina, it's going to be like this. It's just not that simple. So what we're going to do as we go throughout the duration of this video is look at, okay, what about this year's La Nina? What is different about this year compared to some of these other years, or how does this year look in similarities, like which year matches the best as a whole, and going even beyond just these years, going even a little bit further out back to the early 1990s with some of these years, looking at some years that were borderline La Nina as we go throughout the duration of this video. And this is a great place to start with the type of La Nina, because there are arguably 2 to 3 different types of La Nina just in terms of where the ocean waters set up, where the coldest ocean waters compared to normal set up. This is a look at eastern-based La Ninas. These are not quite as common, but we've had a couple in the past 10 years, 2021, 22, and 17, 18. And what you notice here is the coldest waters associated with La Nina tend to be close to South America and east of 120 west. If we draw a line right here, typically the coldest waters are east of that line. If we take a look at what years that have an eastern-based La Nina typically do in winter, you typically have a lot of high latitude blocking. You get more of a negative NAO, you get more of a negative AO, you get Pacific blocking. These winters tend to be colder overall on average, and you can see here it forces a lot of cold air south down into the United States. A lot of people get excited when we talk about eastern-based La Ninas because historically speaking, they do tend to be a little bit colder overall across the northern and eastern tier of the United States because of this blocking signal. What about central-based La Ninas? This is a more common La Nina. It happens more frequently. Last year was considered a central-based one, 2023, 21, 16, all the way back to 1999 there. And you typically get the coldest waters a little bit closer to the date line, between 180 and 120, typically with the coldest waters more so over the date line compared to closer to South America. These years, historically, while again, there's some variability in here, they tend to be a little bit warmer as a whole. The colder air tends to be bottled up a little bit further to the north and to the northwest. more often than not, you get a warmer signal across the south and east part of the country. But even among some of these years, last year was colder. 2010-11 was a colder year. And so even among these, there is some variability. So that's important to keep in mind. And then you have what we have this year. I wouldn't say that we're east-based. I wouldn't say that we're central-based. We're kind of mixed, basin-wide, if you will, somewhere in between. The ENSO anomalies are spread out across the equator in a relatively consistent fashion. And so I wouldn't necessarily say that 2024-25 falls into either one of these territories. We're kind of a mix. And so if we look at years that are a little bit more of a mix, kind of on the borderline of both the central and the eastern-based Niña, and we take a couple of years from both the Central Pacific set and the Eastern Pacific set, you have years like 2010-11, 07-08, 05-06, 1999 and 2000, and 1995 and 96. These are the years where, again, you can see the cooler waters are spread a little bit more consistently along the equator. Not quite to the dateline, not quite to South America, somewhere in between. That is where we are right now and overall where I would expect us to go as we go throughout the winter. Now, if we look at these years, it brings up an interesting scenario. While the Pacific blocking signal is not as strong on these years, this type of a look would actually increase the colder risk for the eastern part of the country. Now again, even among these years, there is some variability, but the overall average here would indicate a slightly colder risk to the forecast based off of the ENSO state. So certainly something to watch very, very carefully over the next couple of months, how this evolves. Do we trend more central-based? Do we trend more eastern-based? Do we stay in this mixed kind of area? Right now, indications are we stay more in this mixed area, which is a colder risk to the forecast overall. However, that's not all. With La Niñas, we also have to factor in numerous other drivers, and I would say maybe especially this year, because La Niña is expected to be weak. We're not looking at a strong or a moderate La Niña, and so maybe even more so than other years, the overall intensity of La Niña is probably going to open the door for Pacific Ocean drivers, Atlantic Ocean drivers, stratospheric drivers to have a bigger impact on our winter pattern. I also think that it may limit the impact of the orientation of La Niña a little bit. Maybe the central versus east base doesn't matter quite as much as it would if we were in a moderate or a strong La Niña. So I think it's critical that we look at these other years. So we're going to go through a couple of them, and you're going to start to see a theme that I think is what we are going to see as we work into the winter. Number one, and a pattern driver that we call the QBO. It's a measure of the stratospheric winds. It basically helps determine whether the polar vortex is strong or weak in the winter. That's very important. A weak polar vortex, you spread colder shots of air down into the mid-latitudes. A stronger polar vortex, all the cold air gets trapped up to the north over the Arctic. Based off of this mix of weak La Niña years and a negative QBO, you tend to get high latitude blocking over the Arctic, a weaker polar vortex, and shots of cold air down into North America. Now, these years don't necessarily favor a big negative NAO, a big high pressure over Greenland. There's a misconception that a negative QBO with a La Niña automatically means a negative NAO. That's not the case. You can go back to the very last one we had, 21 into 22, overall did not have a negative NAO throughout that winter. And so, to me, this signal is more about what we call the negative AO, high pressure over the Arctic, and what we call a positive TNH, cold air lingering over the Hudson Bay. That's important because it can lead to a tap to colder air with storms as we go into the winter. It can increase bigger winter storms. We had that at times last year, and we saw some big winter storms pretty far south last winter. What about the Pacific Ocean? Our PDO state continues to run very negative right now. We look at years with similarities. Well, look at this. Number one, a big ridge in the North Pacific that can allow for cold air to dive down across North America. But look at this. You have this positive TNH signal, this Hudson Bay vortex signal, just like the QBO would indicate. So we're starting to get some agreement among our pattern drivers. What about the Indian Ocean? The Indian Ocean helps determine what tropical forcing is going to do as we go into the winter. We look at years with a weak La Niña and a negative IOD as we head into winter. Look at that. Also, a Hudson Bay vortex. cold air source sitting right here over parts of Canada. This would actually be even a slightly cooler risk into the northeast part of the country because these years have a little bit more blocking over Alaska and over the Arctic and into Greenland. And so overall, the theme with these three signals here, 1, 2, and 3, they all have that cold air sitting over the Hudson Bay and over Canada. What that can ultimately do as we head into the winter is it can lead to big shots of cold. Doesn't necessarily guarantee that we're going to see sustained cold. It would probably favor some ups and downs. But to me, this type of signal increases the risk for big winter storms, and it opens the door for big cold blasts of air. Now, what you will also notice with all of these analogs, a little bit of a southern southeast ridge, southern southeast ridge, southern southeast ridge. And so that's a warmer risk across the southern tier of the U.S. I think it's going to be more difficult this year compared to last year to get those cold air blasts all the way down to the Gulf Coast. We saw record-breaking snow along the Gulf Coast last year, a lot of snow in the Ohio and parts of the Tennessee Valley. Kentucky had a ton of snow last year. I think the storm track as a result will be a little bit further north as we head into this winter. Taking a look at some model data, we've got support for this idea. This is December specifically on the INSEP model, the CFS model. Look at the cold air source. Don't focus so much on all the oranges you see across the U.S. It looks warm. But if you look at the actual teleconnections here, a big ridge of high pressure, negative EPO into Alaska and the Arctic, and this cold air source sitting over the Hudson Bay, not much of a negative NAO signal, which I'm okay with. With this type of a setup, this would allow for shots of cold air down into the U.S. as we go into winter. And so with all this in mind, all of this combined, we updated our analog set. We took out 2022 for now, added in 2007, even though it's a stronger La Nina. It had a lot of similarities with the IOD, had similarities with the PDO, had similarities with the QBO. Those are the three pattern drivers we looked at. You add that into the mix and you get a cold air source over Canada, over the northern tier of the U.S. consistently as we go throughout this winter. We don't have a lot of blocking over the Atlantic, and so it will be difficult to get those colder shots of air down across the south and east part of the country, but this would pose a slightly cooler risk and an active storm track into the interior northeast as well. And if we look at what the temperatures overall averaged out to be with these years, you can see core of the cold, parts of Canada, upper Midwest, into the Great Lakes. I don't disagree with that. That's exactly where it should be based off that upper level pattern, but not as warm in the Northeast. I think there can be a lot of ups and downs this winter in the Northeast, but the trend right now with pattern drivers and analogs is a little bit colder than the initial thought in the Northeast part of the country. With this type of a setup, to me, this would favor a big winter storm track somewhere through this region as we go throughout winter. And so bringing in maybe some better snow chances into the interior Northeast, still skeptical about the mid-Atlantic, kind of New York, Washington, D.C., Virginia, through that area in there, and then into the Carolinas. But, I think Midwest, Ohio Valley, Great Lakes, interior Northeast part of the country, with this type of a setup, with this type of a signal that we're seeing, could be very interesting for winter prospects. Now, the other thing that I want to make very clear with this is not a massive cold outbreak consistently type of winter. With the southeast ridge tendency, I do think it will be difficult to necessarily get 3, 4, 5 weeks in a row of sustained cold. I think there can be big cold blasts, but maybe just not consistently like a 13, 14. I think some similarities in terms of how temperatures evolved to last winter, maybe just a little bit warmer south. Maybe the cold shots are a little bit more notable to the north, in the north central part of the country. That's where we are at right now, guys. As usual, if you have questions, don't hesitate to reach out. Thanks for watching. We'll chat soon.